I just bought this hoverboard from a second-hand app for only $25, and it has everything that I need for a project because you see, I want to make my own wind turbine because recently I bought a small field in my village and I want to add solar panels, a wind turbine, maybe a greenhouse, and just relax there in the weekends. So I thought instead of just buying the wind turbine, why not just make my own? So for that I will try different motors like a washing machine motor, my own 3D printed motor, but I also want to use this kind of motors. So for only $25 from secondhand, I have the motors, I have the charging unit, I have a battery pack, I have a brushless motor controller, some switches and much more. So you should never throw this away. Even if it doesn't work, you can still use it. So in this video I want to tear this down, show you what you get inside of this hoverboard and show you what you can do with each part, and then I will put this motor to test and see the maximum power using my drill that I could get out of this, and maybe in the future I will use 3 of this in a series and create a very powerful wind turbine. That being said, let's get started. Check this out guys, even inside of this motor we have a tiny PCB. Nowadays PCBs are everywhere, that's why I want to talk about the sponsor of this video, PCBWay, because if you have some kind of prototype or you are working on a project, if you want to make professional PCBs, you should definitely check their services for PCB prototyping, but also for CNC milling of metal parts, of mold injected parts of plastic or 3D printed parts, and much more. I work a lot with printed circuits and I think I've made more than 100 PCBs, and each time that I use their services, I get very good results. The tracks are perfect, the VS are perfect, everything is working nice, and the prices are so low that even if you make some kind of mistake, you can reorder the PCB once again, getting better and better till you have a final product. So have in mind, the next time that you have a project with a PCB and you have some Gerber files, check the PCBWay for their services. And now let's continue with this video. What's up my friends, welcome back. So I bought this hoverboard from a second-hand app which is called Wallapop here in Spain. I'm not sure if it's worldwide, but anyway, you can find a lot of this online because for some reason, a few years back this was very popular, but this is just for kids. I mean, I never seen an adult use it. I mean, I know that the electric scooter is used a lot to go to work and to use it around town, but this is more like for kids to play inside or maybe just in the park. And if they got damaged or maybe bored or the kids are now grown up, they don't use it anymore. So you have a lot of this online on eBay, on AliExpress for just $20, $25. So on this app that I've used, I've searched like 20 or 30 of this like for only $20 just in my area. So imagine if I search in the entire country or entire Europe. So anyway, if you have one of this hoverboard and it doesn't work anymore, don't throw it away because you have a lot of parts that you could take out. For example, you have 2 brushless motors, and these are low RPM brushless motors. That means that with a very low speed you can generate a lot of voltage if you use it as a generator. And also in the inverted option, it will spin very smooth and very at low RPMs, and that's why you use it with a hoverboard, because inside it has a lot of poles and a lot of magnets, so just for very slow spinning you can generate a lot of voltage. You also get a huge battery pack. As you can see, this is quite heavy, so you have a battery pack inside with those 18650 batteries. You have a BMS for sure with a charger, you have some switches, and you also have a very powerful dual brushless motor controller which you could use with a remote, which I have here. This is the remote that I have. It just has to turn it on, to play some sounds via Bluetooth and go forward and backward. But anyway, you can use this with Bluetooth and control that driver and maybe connect it to any other brushless motor. And just for you to understand, $25 for this is very low price, because only this kind of motor, for example, I will show another motor that I bought, for example, for my electric scooter. I bought that with $50, and that's a lot of money just for one motor, and you get 2 of these, and these are huge. These are very big and very powerful. So what I will do today is to tear this down and show you what we have inside part by part and show you what you could use this for, and then I will put this motor to test and see the maximum power that I could get if I were to use it for a wind turbine, and I'll measure the speed, the power output, the voltage, the current and everything, and then I will share that with you. So let's get started. Hey guys, just a small pause here. This is me from the future. This is the next day. And I just wanted to tell you that I don't want you to waste any time, because I haven't reached the goal for this video, because I haven't reached the maximum power of this motor. As you can see, I've opened it and I will show you what we have inside, what you get from the hoverboard. I even measured the power, but unfortunately my electronic load got busted because this is homemade, and that's what happens when you use homemade parts. And I haven't reached the maximum power, so I had to use this other electronic load which can only reach 100 watts. So for sure I know that it can reach 100 watts, but I'm not sure if I can reach even more than that, maybe 200 watts. So I will have to make a setup for this motor because I don't have enough power to spin it with my drill. But anyway, I still recommend you to watch this video because I'll show you the rectifier circuit, how to measure properly the power even if I don't get the maximum power, and how to make the circuit, and how I'll make my wind turbine, and so on. And most important, how to use this as a generator with triple phase output, and what you get out from a hoverboard, all the parts that you need. So now you can continue with the video, and I hope that you won't waste any time. So if you don't want to see this video because I don't reach the maximum power, just skip it and watch my next video. Now let's continue. Okay, so to open this up should be very easy because all we have are some screws all around this, and then I think that we can take this out and have access to all the electronics. So that's what I will do first, and then we will even test it to see if it works. But let me just open it up.
The Bluetooth device is ready to pair.
Damn, that's loud. So as you can see, it turns on, but it doesn't charge. So I'm not sure if it's the charger that's wrong. By the way, this is 42 volts and 2 amps. So we should have that in mind in case that we want to charge the battery pack. And this is what we have inside. First we have some kind of very strong metal frame, because obviously it should withstand your weight. Then we have the switches here. When you push it, I'm not sure you can see this, but when you push it, you have this switch here, and that's to detect when you are pressing with your feet, because if you're not on top of the machine, it won't work. Then we have these two boards here, one here and one here, and I first thought that this is just one driver for each motor, but actually the driver is here, as you can see all the MOSFETs, and then we have 3 wires that are coming through this and going to this motor. These are the 3 wires for the motor, and then other 3 wires, this here, that are going to the other motor. So this is the driver, and these are just for the switches. I think this is a light that turns blue and red, and this is just for that, for controlling that. And then we have here the battery pack. I thought it would be a lot bigger than this. Actually, I thought it will be half here and half here, but I think they managed to put the entire battery pack here, and I'm not sure how this, I think is more weight in this side than the other side. First thing I will do is to disconnect the battery, so I make sure that I won't make any short circuit and make this battery explode, because this can be quite dangerous. So disconnect it, and then I can take everything out. Okay, so this behind me is everything that I've took out from this hoverboard, all the parts including the mechanical parts, so let me show you one by one. There are some great parts that you could use from such a board, so once again, never throw this away. Okay, so first of all, the motors, which by the way, I couldn't have the patience and already connected it to my multimeter here, just one phase, and just spin it just a little bit and it reached 20 volts. Which for me is already a good sign, because if I get more than 15 volts with this, I'm more than happy, because the battery that I will use with my system will be 12 volts. Anyway, we'll see that. So we have the brushless motors with the sensor inside. We have these 2 boards which are we will control some lights, but I can also see a radio controller here, a radio module, which I think is for this controller to go back and front and turn the lights on. Then we have the main controller for 2 brushless motors, and I think that this already has the BMS and the charging circuit, because the battery charger is connected here and that goes to the battery, or maybe the BMS is already here inside of the battery pack. We'll open this in a moment. And then what more? We have a bunch of screws, and these are not all the screws because a lot of them fell on the ground. Then we have the mechanical parts. You could salvage from this maybe the bearings here and this bearing system, because this is quite useful. Then we have a speaker here, we have a Bluetooth receiver module for music, and this actually works by its own. You can connect music to this and play the sound on this speaker, because this is independent from the rest of the circuit. We have the on and off switch and the charging plug, and some more LEDs here, and the other LED will be here, and that's it. That's all you get. These are the mechanical parts and plastic, but these are the important parts. A quite good battery pack. I'm not sure if it works, but it's quite big. I hope that it works. The controller, the motors, and these drivers and radio receivers, which I'm not sure if I could repurpose this for other things. Actually, this control is quite awesome because it's dual. You can use this for maybe an electric skateboard or an electric bike. It's quite powerful. I'm not sure the maximum speed that it reaches because with this motor the speed was quite low because these are low RPM motors. They have a lot of poles. But if I connect a different motor, like for example the motor that I've used with my electric skateboard, I try to put that on the screen, it will reach a lot more speed. And this is dual, so you can control two motors at the same time. And I'm not sure the power of this. I would search it online, but I think it's pretty decent for an electric bike or an electric skateboard or any other project that you have. It has its own heatsink, so it's pretty cool. I will save it for another project. Okay, so the charging voltage was 42 volts, but this is of 36 volts. So I will open this and see if it still works. And if it's very low voltage, that means that at least one of the cells died, and that also means that probably all the cells are dead. So, and yes, as I was expecting, the battery voltage of this is very low. As you can see, is 14 volts and it should be 36. So basically that means that at least one cell is dead, so we don't even have to open it. Actually, I will open it and test one by one because maybe I'm in luck and only one cell is dead and I can change that and still have the battery pack. Actually, this is a cool battery pack. I could even use it for my solar system because I don't require much power for my field for now. So I will keep any battery that I have from here. I will keep it if it works. And yes, as I've been told you, the BMS is inside. Maybe the BMS is damaged. But anyway, I can see leakage here. Yes, that's oxidation and leakage. We will see. So as you can see on this side, for example, these batteries are, let me just connect my multimeter, 2.8 volts. So I think this is still salvageable because I can still recharge it. But on this other side, this one is 1.2 and this one is 0.8. So these two batteries for sure are dead, and I think these other two as well, which are exactly the batteries that I have the oxidation, but maybe I can just change this for and still have a battery pack. By the way, I just figured out why this board has a microcontroller and you have two of these. I have another one here and they are the same, and I just thought that this will control the lights, and I thought, why would use two microcontrollers just to control lights? Actually, it doesn't just control the lights, because here is where the accelerometer is. And basically you need two of them, because if you know, a hoverboard won't incline altogether, just one side at a time. So you can just change the angle of one side and not to the other. So you need two accelerometers and gyroscopes, and that's why we need two boards. And this will detect the angle and will detect on which side you want to start the motor or not. That's why we need two. So you can just take this out if you need it. And you also have some kind of copy of the STM32 microcontroller in case that you want to take it out, and this radio receiver, which is compatible with that remote that I've just shown you. So you can also use that for any kind of project that you want. And as you can see, for the driver, you have this input for each side, and it's quite easy to control. We have the 12 volts input, the ground, the RX and TX for the UART port, and then we have the hold, and I think this is controlled with the PWM input. So we can easily test this with a PWM output from a radio controller, from a normal RC controller. So for sure we'll use this for a future project, and maybe an electric bike or skateboard. Just change the motors for ones that are a lot more faster, make the PWM input, maybe an Arduino, and maybe I could also salvage the battery, and we'll have everything that we need for a cool project. Everything with only $25. And finally, we have the most precious part of this hoverboard, the motors. And as you can see, I've told you that the wires coming through the axis of the motor, and that means that we can rotate it without rotate the wires. And that's very important, because if I want to fix this on a propeller for the wind turbine, we don't need the wires to spin at the same time. And I've already told you that I've tested with my multimeter, and I've got from 16 to 20 volts just for one phase, and that was AC. So basically what we need to do now to test it, I want to test the real power if I were to use this for charging my batteries. So I won't test the power in AC, I will test it in DC. So I'll add a rectifier, a triple phase rectifier at the output with the diodes and capacitor. I'll rotate this at a constant speed with my drill, measure the speed, measure the power output, and make a graph and share that with you. And in a future project I'll put at least two of these together, because To place two of these together, all you have to do is to place them face to face, and that's it. But if you want to place more than two, you have to cut the core on half, remove the axis, weld it on top of the others, and it gets messy. Or maybe I will place maybe three like this and have a middle axis in between, a middle shaft, but that will add gears, so more friction, more sound, and I don't want that. What I want to do is to place them face to face, something like this, and then place them on a propeller and just generate power. But I also want to open it and show what we have inside, because the poles, the winding, and all the configuration inside of these motors is quite awesome, and I really want to share that with you. Just to compare, these are the motors that I've used for my electric longboard, and this cost me like $49, and I bought two of these because I wanted to make it dual drive, but in the end I made it only with one motor, so $49. And look at the difference in size. And actually this is low RPM, so it spins a lot smoother. You can use it even with an electric bike, and this cost me $64, actually euros, which is more than dollars. So these are quite expensive, so having this for only $25 with the rest of the parts, I mean, it's a no-brainer to throw this away. So now I just want to test this motor, but I'm not sure how to connect this to my drill, because it doesn't have any shaft on the other side, and it's also quite heavy, so I have to make some support. So what I want to just, before testing it, just open it up, and maybe I can remove this rubber, maybe place it on some sort of support, and then add the drill here up on the top side, or maybe just add it here on the rubber. I'm not sure. I will test something and then test the output, but I also have to make the rectifier. So for that, let me just explain you how we measure power of a generator. So how can we test the maximum power of such a brushless generator? Because it's not just the output power in any given moment, it's the maximum power. So if, for example, you add a light bulb of only 100 watts, let's just say that this can create more than that, it will use 100 watts. Even if you spin it faster, it will still use 100 watts because the resistance of the light bulb is fixed, and even if the voltage is a little bit higher, maybe it will burn it, but even so, the power, it won't be the maximum power, because if you add two of those, maybe it will give you 200 watts. So basically what you have to do is to just try different speed, keep it constant, and then use maybe a variable load or an electronic load to change the resistance, to make it smaller and smaller and smaller, till you get a peak and the power starts to get lower. And that will give you a graph. You test it with different speeds, and then you get the actual maximum power of your generator. To understand better, I prepared this graph for you. So on this axis we have the shaft RPMs or the wind speed, and on this axis we have the power. And each of these graphs are for a different resistance. For example, we start with 200 ohms down to only 20 ohms. The smaller is the resistance as a load, the higher will be the power, because the voltage and the current will be the same, but since the resistance is lower with the same voltage, more current will pass, more power will pass. But as you can see, the higher the RPM gets, the power also gets higher, but then we reach a peak and the power will go down. And that's basically because the higher is the RPM, the higher will be the voltage, but the resistance of the load is the same. The higher is the voltage, the resistance is the same. That means that the current will also want to get higher, but it will reach a limit where the motor, because of the wires, of the winding and the magnets, can deliver more current that the load is asking for. So that means even if the RPMs are getting bigger, the current will get lower, because the motor can deliver more current than that. It can deliver more voltage but not more current. So basically we should get something like this graph. So we have to try different resistance, different speed, and make this graph for this motor and test it how much power we will get. Okay, the first test, which is pretty crude, before I add the rectifier, I just connected one phase to my multimeter in AC mode. I'm not even sure this is RMS. Yes, it's true RMS. So I'll just spin it with my drill and see the maximum voltage for only one phase. Let's just do that. Just place this multimeter here. But as you have seen, if we've reached 28, I have placed it in maximum. So we reached 28 volts, which for me actually is more than enough. Okay guys, so now to get DC from this triple phase, I'll make a rectifier. This will be a triple phase bridge, so we need 6 diodes. and I will use these diodes. This can go to quite some power, they are quite big, but for the final project when I'll make my wind turbine, I've already designed a PCB with some awesome diodes that can go up to 1000 watts. We also need to add a capacitor, maybe two. I'll make a simple circuit, and remember, we've got like 20 something volts just for one phase, and that was with my multimeter. So basically a peak to peak value, I've already measured it, will go over 40 volts. So I mean, these are 450 volts. With 100 volts capacitors you will already be good, but this is the only thing that I have right now. So let me just make the circuit, connect it, and then measure the output power and the voltage in DC. So I'm watching just one phase with just one diode, so this will be just half a bridge, and all I want to do is to see the peak to peak value and just do the same. Not sure if you can see, but it reached 45 volts peak to peak. Quite nice. Okay guys, so I've made the rectifier. It's very simple, 6 diodes in a rectifier bridge for triple phase, a high voltage capacitor at the output. I've connected them on the back. This is the output DC and this is the input AC triple phase. And that's it. It has no fuse, no bleeding resistor, nothing, just to test it out. So each time that I will charge it, I will have to discharge it with a resistor or maybe just touch the wires here, because I think this will get to 40 volts, which is not that dangerous, but it could create a lot of current, get hot, and so on. So yeah, I will connect this to the motor and test the voltage and then the power. Okay, so I have the multimeter connected now in DC mode, and just as before, I will spin it with my drill. And we get 40 volts, and it stays like that because I have no load attached. Actually, I have this resistor and I'll add it to discharge, but we reach DC 40 volts, which is amazing. Let me discharge it. There you have it, is now discharged. Okay guys, so I start doing the tests and I encounter a few problems. First of all, I wanted to use my electronic load. This was meant to work up to 500 watts. It never reached that power, but even so at around 100 and something watts, it burned out. That's why this is homemade, and this was maybe the proper test to make, because when I was making this project, I only reached like 50 watts and I never had problems. But now I'm not sure if the voltage was overpassed or the power burned out the MOSFET and the cooling didn't work. Anyway, this was a homemade project, but I have another electronic load. This unfortunately only gets to 100 watts, but even so I had different problems because I never reached 100 watts. First of all, it was very difficult to keep this in my hand, so I stick this together here with the body that it have, and I've added the screws, so now it's easier to rotate. But when this is connected to the electronic load, it creates so much force, and the only thing that I have to spin it right now is my drill, and there is not good connection, and I've already reached like 90 watts, so I haven't even reached the limit of this electronic load. So I'm not sure how to keep making the test, because I have to make some sort of connection here and maybe connect a bicycle or a different bigger motor in order to proper spin this, because without a propeller for the wind turbine I don't have the power to spin it. As you can see, it requires a lot of power to spin. In a moment I will show the power that I'm reaching here just with the drill like this. Actually, as you can see, the rubber already starts to wear out because of the friction between the drill. I would like to maybe place some hole here and connect the drill directly to that, but even so, this requires a lot of power to spin. So not sure how to get the maximum power. So guys, I actually am a little bit disappointed because I promised you that I will test the power output of this motor, because I wanted to have real data, because I've searched the data on the internet and there are a few other videos and other posts on the internet that talk about this motor. Usually a hoverboard like this one is around 700 watts. It uses 700 watts, that doesn't mean that it will generate 700 watts when you put it in generator mode. But even so, some other guys on the internet are talking that they were able to generate more than 200 watts with one motor like this one. And I would like it to put it to the test, but this electronic load right now only reaches 100 watts, so it will be very difficult for me to reach that, so I have to buy another one or repair mine because it got broken. And also, I think I will have to use a very powerful motor to spin this. So I'll have to open this motor, add a shaft or maybe some gears, and then connect that to another powerful motor that will control the speed, and like that make the tests. That's why for now I'll show you the power that I can reach like this with the drill. And as you can see, This is supplied with a USB cord or USB cable for 5 volts so I can power the load, and then at the input I've connected the output from this rectifier. So we'll see here the voltage, the amperage and the power, and also the resistance. So let me just spin it with my drill and check the power here. I hope that you are able to see the power here because it's a little bit difficult to make this setup. Let me just spin it, see the power, the voltage and everything on the screen. We've seen 18 volts and like 87 watts. That's the maximum I can do, and I don't know if you can see, but there is a lot of plastic and rubber coming out of this because this creates a lot of friction. I can barely move this with my hand, imagine with this drill. Now don't believe that those 80 watts is the maximum power of this motor. It can deliver a lot more, I'm sure about that, but this was limited to like 80-90 watts because the maximum power of this is 100 watts. And I'm pretty sure it won't get 100 watts because it has limitation inside. So that's why I need a bigger electronic load, or maybe even make my own variable load with a nichrome wire and change the resistance and like that change the load. So guys, I know that I already have my own rectifier, but while I was recording I received this, and this is also a rectifier that I've ordered to make the prototype. And then I'll try to place on the screen the PCB that I've talked about because I made my own PCB for a full bridge rectifier for triple phase, very powerful, each diode with its own heat dissipator. It can reach 1500 watts. And just so you know, you could also buy this one, which is already the rectifier inside. As you can see, it has the triple input, the triple phase input AC, and the DC output. Obviously this is without the capacitor, so you should connect the triple phase bridge here and the capacitor here, and you will have the same as this one. And it will be easier to make instead of soldering your diodes. And it already has a heatsink, which I'm not sure if for 1500 watts is enough. I would put a little bit more on top, or maybe even a cooling fan. But just so you know, you could buy this directly and clip it on your board. So guys, what is the main idea of this video? It was a fail. Usually when I make these kind of videos where I just start, open the project and record it without a previous attempt, sometimes it happens that I can reach the goal that I have for the video. And that's bad for you because I don't want you to make you waste any time. So I'll re-edit the intro of this video and I will tell you at the beginning that I didn't reach to make the curve of this motor, so I will only show you what you get inside. So I'll record that, place it at the beginning, so if you see this video, if you want to see it entirely, just watch it. But I will announce at the beginning that I don't reach the maximum power because I don't have a good setup and I wasn't prepared for that. But actually we have seen what we have inside, and I'm pretty sure that I've already reached 100 watts with this motor, which is more than enough for me, but I'm pretty sure I can get even more, maybe 200 watts, and with two of these motors connected in series. By the way, the output of the motors, if you want to merge them together, don't connect them together, because it might happen that one phase could be on the positive side and the other phase from the other motor on the negative side, and they will subtract one from each other. So you get a null output or a very low voltage. Usually what we want to do is to connect one generator to a rectifier, the other generator to another rectifier, and then the DC voltage, which will always be positive, you can merge them together, place them inside of connect them to an MPPT, and then charge your batteries. So guys, that's it for this video. I hope that it will help you at least to see what we have inside. And by the way, I've told you that I will open this motor, which I'll do right now, and show what we have inside of the motor. But now you have an idea that what you could do with a hoverboard like this one, and also that at least we can reach 100 watts. I haven't reached the maximum power. I hope I will reach it in a future video where I want to make a proper test setup and test this motor, a washing machine motor, my 3D printed motor, and even some small brushless motors that I have, like for the motors from my electric longboard. And then design and 3D print the parts, weld up metal parts for the wind turbine, and then place it on my field and test the output with a very good MPPT. Well, at least I was able to take this top part out, and I'm not able to take the stator because, as you can see, it has a lot of magnets, and this is a two-man job, or at least maybe tie this to some sort of machine and then pull it with my hand, because it's very locked there with the magnetic field. But as you can see, Let me just count the rotors, the stators, the coils, the poles, and also the magnets. So I've counted 27 poles and 30 magnets. So it's 30, 27. That's why this is a low RPM. It has a lot of poles, so it will rotate very smooth, but at the same time with very, very low rotation, it can generate, as you've seen, up to 40 volts peak to peak. So this is what we have inside. The connection, I think this is a delta. This is a delta connection. No, I think this is a star connection because I see here that all the wires are connected together. And then these are the sensors, which I think they are Hall sensors and are on this PCB or maybe even inside. Actually, I was able to take it out. I would just grab this with my feet and then with my both hands I pull this out and we have the rotor, the stator actually. And what's interesting is that I saw that the Hall sensors are embedded into the metal of the stator. As you can see, we have 3 sensors. Definitely these are Hall sensors, and then those will be connected to the driver. So we have the stator here. It's quite nice. Actually, what I'm planning to do is to take both stators from both motors, add some holes here, merge them together, and then make some sort of sandwich between this outside part and the other part. And like that I can take double the power using 2 generators. I think it's quite cool to see this, right? So guys, I know that we haven't reached the goal for this video to measure the maximum power of this motor when I use it as a generator for triple phase generator output. And I'm sorry for that, but at least we know that we can reach at least 100 watts, which for me is, for now it's enough, because what I'm planning for my field is to add some batteries and I will only go there in the weekends. So during the week, it will charge up with maybe 100 watts or 200 watts if I use 2 of these. It will charge up the battery. When I'll go there for like 4 or 3 hours, I can turn on the lights, maybe play some music, have my Wi-Fi router with 5G, and that's it for now. In the future, I will expand that with solar panels and more. So sorry that I haven't made the curve for the power, which is the same that I will show you in just a few moments on the graph. I wanted to make the same graph for this motor, but at least we know what we can take out from the hoverboard, what we have inside, how many poles. We can reach at least 100 watts. I've also shown you the circuit for the rectifier and also told you how you should measure the maximum power, even if I haven't made that. I hope that this video will help you and I haven't made you waste your time. That being said, thank you very much and see you in the next video. Keep up, you guys. Hey guys, I just thought about just one more idea, one interesting thing that I should tell you. Do you know what limits the power output of a generator? Is the RPMs, is the voltage that it creates, the amount of magnets, or what? Basically, you could get the maximum output just by short-circuiting the output like this, because in that way, all the voltage that is created will be over the resistance of the coils, which could be like 1 ohm, 2 ohms, but that would be the ideal power. And all the power will be wasted inside of the generator, and it's very difficult to measure because you don't have a voltage drop, because there is a short circuit at the output. That's why we need to add a load at the output and measure the power, the real power that it could output, not the power that is generated inside. And usually the power for this generator is limited by the wire, because the wire, the thicker is that the wire, the lower it will be the resistance, more current could pass, it won't burn out, and also the amount of loops that you can create. That means that the more loops you have, more voltage you will have. Also the force of the magnets. The bigger is the force, more magnetic flux you will induce into the coil, and that will induce more of current, creating more voltage. So all these terms are limiting the power output. So usually when you have a generator, for example, for my car alternator project that I've made, if you want to get more power, what you could do is to rewind the entire generator with a thicker wire. Like that you can get more current and it won't burn out, and the resistance of the internal coils will be lower. It's an interesting fact that you should know about generators. And I'm still waiting to know the power of this generator here. I hope that it will get at least 200 watts. Together with the other one, maybe 400 watts. It will be more than enough for me to have my greenhouse, some sensors, some Wi-Fi connection, and some lights with LEDs. Now yeah, thank you very much and see you in the next video. So guys, here I am in my workshop, another video that ended. I hope that you like it. And the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel. So thank you very much once again.